Okay, so in this worksheet, you want to solve each of the following inequalities, and they want you to write the solution in both interval notation and set notation. So notice that in some of these problems and some of these inequalities, you have fractions involved. So I'm going to go ahead and do the work on another sheet of paper because I may not have enough room here. Do notice though that some of them do say show work. So if it says show work, you have to show the work. These did not, but I'm going to go ahead and do the work anyway. But if it does say show work, you must show work. All right, so let's look at number 1. So I'm going to go ahead and write number 1 here. So this will be number 1. So number 1, we have 2/3 x is less than 8. All right, so I'm trying to get x by itself, right? So right now, I'm multiplying by 2/3. And the opposite of multiplying by 2/3 is to divide by 2/3. I'm going to go ahead and write this over. So I'm using the division property of equality, in this case, inequality. All right, division property of inequality. And then notice what I do to one side, I do to the other. So 2/3 divided by 2/3 is 1. So I get 1 times x is x. It's less than. Now you see this right here? This right here? Let's go off to the side and kind of talk about this. So I have 8 divided by 2/3, right? Well, remember in a previous course, you know how to divide fractions. So this 8, I can think of as 8 divided by 1. So whenever you have a fraction divided by another fraction, you're going to change this division to multiplication. And one way to change this division to multiplication is to multiply by the reciprocal of the fraction that's in the denominator. So the reciprocal of 2/3 is 3/2. And so now I'm multiplying fractions. So I went from dividing fractions to multiplying fractions. And so to multiply these two fractions, let's go ahead and reduce first. 2 to 2 is 1. 2 to 8 is 4. And so you get 4 times 3, which is 12. So I get x is less than 12. So the solution to this inequality, so the real numbers that will make this left side less than 8 is any real number that's less than 12. All right. So for example, just to kind of show you, so let's pick a number that's less than 12. Like let's say 9, right? So let's look at 9. So let's just check x equal 9. So I'll go back to the original. So I want to see if I substitute 9, if this is going to be less than 8. So I get 2/3 times 9, and we'll see that's less than 8. Well, 3 to 3 is 1, 3 to 9 is 3, 2 times 3 is 6, and 6 is less than 8. All right? And notice that 14 is not in here, so let's see why 14 is not. So let's just check x equals 14. So 14 better not be a solution because it's not here. It's not in here. So I get 2/3 times 14, and we'll see if that's less than 8, right? Well, 2 times 14 is 28, so I get 28 divided by 3, and I want to see if that's less than 8. So let's go ahead and change this improper fraction to a mixed number. So 3 to 28. 3 to 28 is 9. 9 times 3 is 27 with remainder 1. So this right here is 9 1/3. So is 9 1/3 less than 8? The answer is no, because 9 1/3 is greater than 8. So that's why 14 is not in here. All right. So I just wanted to kind of remind you how to check these and to understand what this really means. So any number less than 12, any real number, any rational number less than 12, any irrational number less than 12 will be a solution to this. Okay? Now, what they want you to do, though, is they want you to put this in interval notation. So I'm going to go ahead and write the solution here. So remember, the solution is x is less than 12. So in interval notation, keep in mind what this means. This means that my solutions will be any number less than 12. So 12 is well, I don't want to say the largest because it's not equal to, but any number up to 12 is a solution. So you're going from negative infinity to 12. Make sure you understand that this is this. Because if you look at this on the number line, just to show you, if you look at this on the number line, here's 12, right? And you're going to the left. So in terms of your interval notation, you go from negative infinity to 12. Now remember, since there's no equal sign, you're going to put parentheses. That's important to recognize. And now set notation, that's easy. You're going to say the set of x's such that, and you just write the inequality, such that x is less than 12. And that's all you do. Okay? So I'm just going to put the work is on other page. Work on other page. And that's going to be the same for all of them. Okay, let's look at number 2. So number 2, we have this. Now I'm trying to find all the real numbers. It says that when I multiply by negative 3/4 is going to be greater than or equal to a negative 12. All right, so let's talk about that. So let me go ahead and rewrite this over. So here's number 2. You have negative 3/4 y is greater than or equal to negative 12. So the same idea as before in it. So to get x by itself here, I had to divide both sides by 2/3 by that coefficient. Do the same thing here. So here's your work. I'm going to go ahead and rewrite this over. And so to get y by itself, you can divide both sides by negative 3/4. But here's what you got to remember. Look, I'm dividing an inequality by a negative number, right? So remember that property that when you multiply or divide both sides of an inequality by a negative number, in this case I'm dividing by a negative number, you must reverse the inequality symbol. You must reverse the inequality symbol. Okay? So when I reduce this, negative 3/4 divided by negative 3/4 is 1. 1 times y is y. But now this becomes less than or equal to. And now let's, just like we did this right here, we went to the side, let's do the same thing here. Let's take this right here, negative 12 divided by negative 3/4, and let's change that division to multiplication. So I get negative 12 divided by 1 times the reciprocal of the denominator. The reciprocal of negative 3/4 is a negative 4/3. And let's go ahead and reduce. 3 to 3 is 1. 3 to negative 12 is a negative 4. Now look, a negative 4 times a negative 4 is a positive 16. So the solutions will be any real number that's less than or equal to 16. Okay? All right, now, so we get y is less than or equal to 16. So that's my solution. So before you put that in interval notation, you may want to think about what the graph looks like. So here's 16 with a closed circle because of the equal sign, right? And you want all the real numbers less than that. So notice this arrow is pointing towards negative infinity, and when writing interval notation, you always go from left to right. You always go from smallest to largest. So I'm going from negative infinity with parentheses to 16 with a bracket because 16 is a solution. It has an equal sign. You have a closed circle, 16, closed circle, bracket, 16, 16. Infinity, negative infinity will always have parentheses. Never use brackets with infinity, negative infinity. Okay? And so interval set notation is you're just going to use this in it, this inequality. So you get the set of y's. Make sure you see your variables y, so you must use y. Set of y's such that y is less than or equal to 16. All right, number 3. So let's go ahead and do number 3 here. So here's number 3. You have 2x minus 5 is less than 1. So you're trying to find all the solutions to this inequality. So you're trying to find any real number of x that will make this side less than 1. So there's no way you can look at this, so you have to do this algebraically. So you're trying to write equivalent inequalities here, so that way you get x by itself. So here's your work. You're going to add 5 to both sides. So we have this very nice, it's a very simple linear inequality. So when I add 5 to both sides, negative 5 and 5 is 0. Combine like terms, you get 0. 2x and 0 is 2x. It's less than 1 plus 5 is 6. And then you get x by itself. Right now I'm multiplying by 2. The opposite to divide by 2. Now notice I'm dividing by positive, right? So you don't change the inequality symbol. The only time you reverse the inequality symbol is if you divide or multiply both sides of an inequality by a negative number. See, this is a positive number. And so 2 divided by 2 is 1. 1 times x is x, so x is less than 3. So you found your solutions. So any real number less than 3 will make this inequality a true statement. And so we're going to put the interval in set notation. To do interval notation, you may want to think about the graph. So here's 3 with an open circle, and I want any real number less than that. So I'm going to the left. So notice the arrow is pointing to the left. So you're going to say, just like we did here, you're going to say negative infinity all the way to 3. Since that's an open circle, you're going to use parentheses. And then set notation is just where you use this inequality symbol. So you have the set of x's such that x is less than 3. All right, so that's number 3. Okay, let's look at number 4. So number 4, I have, and notice this time it does say show work. So here's number 4. You have 4x plus 1 is greater than 2 times x minus 3. So first thing you're going to do is go ahead and use the distributive property to get rid of these parentheses. So here's your work. So you're going to say 4x plus 1 is greater than 2 times x is 2x, 2 times the negative 3 is a negative 6. So I have this very nice linear inequality. So let's bring all the variables one side, constants to the other. Let's bring the variables to the left. So I'm going to subtract 2x from both sides, because 2x minus 2x is 0. And when I combine like terms on this side, 4x minus 2x is 2x. I got 2x plus this 1 is greater than, and then 0 and a negative 6 is a negative 6. Almost done. So you're going to subtract 1 from both sides. So right now I'm adding 1. The opposite is to subtract 1. That's the only way you can get rid of that plus 1 here, is to add its opposite. And so 1 and negative 1, 0. So I get 2x and 0 is 2x is greater than. A negative 6 and a negative 1 is a negative 7. And finally, we're almost done. So we remember, we're trying to find a solution to this. The real numbers will make this inequality a true statement. I'm almost there. I just got to get x by itself, and then I will have found the solutions. So next thing to do is divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. So my solutions to the original inequality will be any real number that's greater than negative 7/2. Okay? And so when you put this interval and set notation, you may want to, and it's up to you, but remember we found it to be x is greater than negative 7/2. So put negative 7/2 with an open circle because there's no equal sign. So negative 7/2 is not a solution, but the solutions are any real number that's greater than that. So there's your graph. And to do the interval notation, you always go from left to right. So I'm going to start here and go to the right. Since this is an open circle, I'm going to put parentheses. So parentheses negative 7/2, comma, infinity parentheses. And then set notation is where you use your inequality statement. So you'd say the set of x's such that x is greater than negative 7/2. All right, that's number 4. Okay, let's look at number 5. So when looking at number 5, we have this for number 5. And let's think about that. So notice that some students have trouble with this only because of what we're about to talk about. So I have 6 is less than x plus 4. So you see that you have the variable on the right-hand side, and you can keep it on the right-hand side. So what you can do to get x by itself is to subtract 4 from both sides, right? Subtract 4 from both sides. And so I get 6 minus 4 is 2, so I get 2 is less than or equal to x. So you found your solution. So the solutions to this original equality is any number in which 2 is the smallest. Okay? That's what this says. 2 is less than or equal to x. Students have trouble graphing this because they see a less than, and when they see less than or equal to, they want to graph to the left. That's not what this says, though. If you think about it, 2 less than or equal to x means x is greater than or equal to 2. That's what that means. This and this mean the same thing. 2 is the smallest of all these real numbers. That's what that less than means. 2 is the smallest of all these real numbers, meaning that x is going to be greater than or equal to 2. Okay? The other way you could have done it is this. So let me go ahead and rewrite this over. So you could use the transitive property. So if 6 is less than or equal to x plus 4, then this means x plus 4 must be greater than or equal to 6. That's what that means. And so now you subtract 4 from both sides. Combine like terms, you get x is greater than or equal to 2, which is what we have here. Okay? So it doesn't matter which approach you use. Just be careful when graphing, though. Okay? All right, and when I say when graphing, because some students, and this is a mistake, I'm just going to put that here. Some students, when they see this right here that I'm pointing to, they'll put 2 with the bracket, I'm sorry, with closed circle because of the equal sign, but then they'll go to the left because they see less than. That's not true. That and this do not mean the same thing, okay? 2 less than or equal to x is this. Is 2 closed circle to the right. That is this. All right, so be careful. All right, so number 5, we'll go ahead and do that here. So here we have x is greater than or equal to 2. So your interval notation will be bracket 2, bracket because of the equal sign, all the way to infinity. And then set notation, you can say set of x's such that, and then your inequality statement, x is greater than or equal to 2. Very simple process, not difficult at all. All right, let's do number 6. So number 6, it says show work again here. So number 6, we have this. We have 3 times 2x minus 1 is less than or equal to 2 times 4x plus 1, right? Okay, use the distributive property in both cases. I get 3 times 2x is 6x. 3 times a negative 1 is a negative 3. Is less than or equal to 2 times 4x is 8x, and then 2 times 1 is 2. Let's go ahead now. Notice I have a very simple inequality here. No parentheses, no fractions. Let's go ahead and bring the variables to the left-hand side. So I'm going to go ahead and subtract 8x from both sides. And then combine like terms. Notice I have them aligned. So let's combine like terms now. 6x minus 8x is a negative 2x minus 3. Is less than or equal to, this is 0. 0 plus 2 is 2. Adding 3 to both sides, combine like terms, I get negative 2x is less than or equal to 2 plus 3 is 5, right? Okay, now to get x by itself, we got to remember something. Look what I'm about to do. I'm rewriting this over. Look at what I'm about to do. So to get x by itself, I have to divide both sides by negative 2. So remember, in an inequality, whenever you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. So negative 2 divided by negative 2 is 1. 1 times x is x. So you get x is greater than or equal to a negative 5 halves. All right, so x is greater than or equal to a negative 5 halves. So let's go ahead and put that on the number line. Well, so let's draw the number line here. So this is number 6. So here's negative 5 halves. There's an equal sign here, so we're going to put a closed circle. And remember, it was this. We got this. X greater than or equal to negative 5 halves. And so I'm going to shade in everything to the right. So now once I know what that looks like, it's very easy to do the interval notation. So you go from left to right. So bracket negative 5 halves. Make sure it looks like a bracket. All the way to infinity with parentheses. Okay, number 7. So it's number 7. Let's see. All right, so let's look at number 7. All right, number 7, you have, let's do that here. Okay, so, all right, you have 4x minus 7x is greater than x plus 2. All right, this is an easy one. There's no parentheses at all. There's no fractions involved. So I'm just going to go ahead and combine like terms here. 4x minus 7x is a negative 3x. Is greater than x plus 2. Let's bring the variables to the left. So I'm going to subtract x from both sides. when I combine like terms, a negative 3x and a negative x, that's a negative 1x, is a negative 4x is greater than x minus x is 0. 0 plus 2 is 2. All right, now here we go again. I'm going to rewrite this over. To get x by itself, you're going to divide both sides by negative 4, right? So remember our discussion. Whenever you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. So negative 4 divided by negative 4 is 1. 1 times x is x. Is less than or equal to, reverse the greater than to less than. 2 divided by negative 4 reduced is a negative 1/2. You have to reduce. All right, and so that's the solution number 7. So the real numbers that will make this inequality a true statement will be any real number that's less than or equal to negative 1/2. So, oh, and I forgot to put the set notation here. So it'll be the set of x's such that x is greater than or equal to negative 5/2. Okay, over here, we found it to be x is less than or equal to negative 1/2. Okay, and in terms of the graph, we have this with a closed circle, right? Because the equal sign, and I'm shading every number that's less than that. And so in terms of interval notation, go from left to right. So I'm going from negative infinity up to negative 1/2. Parentheses, negative infinity, 1/2, negative 1/2 with a bracket. Make sure it looks like a bracket. And use a bracket because of the equal sign. Use a bracket because of the closed circle. And then set notation, you're just going to rewrite this. You're going to say the set of x's such that x is less than or equal to negative 1/2. All right, not a difficult thing at all. Now finally, number 8. So let's look at number 8. So number 8, we have this inequality. 3 times x minus 2 plus 1 is less than or equal to 2 times 2x plus 3 minus 2x. So you're trying to find, that's a 2 here, you're trying to find all real numbers of x that will make this inequality a true statement, that will make this left side less than or equal to this right side. There's no way you can look at this and come up with the answer. So let's go ahead and write equivalent inequalities so that when we get to a point where I can say something like this, x is less than or x is greater than. Okay? So I do have parentheses. So I'm going to use the distributive property twice. So 3, so everything in here multiplied by 3. So 3 times x is 3x. 3 times a negative 2 is a negative 6 plus 1 is less than or equal to, and they're distributed here. 2 times 2x is 4x. 2 times 3 is 6 minus 2x. Let's combine like terms. A negative 6 and a positive 1 is a negative 5. So this becomes 3x minus 5. That's what this is. Less than or equal to 4x and a negative 2x. Those I can combine here. 4x minus 2x is 2x. And then plus 6. All right, let's bring the variables to the left. So I'm going to subtract 2x from both sides because 2x minus 2x is 0. That's what you want there. Combine like terms, I get 3x minus 2x is x, right? Minus 5 is less than or equal to, and then 0 and 6 is 6. One more step and you're done because you already have an x here, 1x. All you do is add 5 and you're done. Just combine like terms. All my solutions to this original inequality will be any real number that is less than or equal to 11. Now let me write this. Any real number less than or equal to 11. All right? And so to help me with the interval notation, it is easier if I think about it in terms of its graph. So here's 11 with a closed circle going to the left, because that's what this says, any real number less than that. So in interval notation, go from negative infinity to 11 with a bracket. So negative infinity with parentheses, 11 with a bracket. And then set notation is just putting this inequality statement into it. So you have the set of x's such that x is less than or equal to 11. And then make sure you use a brace. Okay? And so that is it. That is the key to this worksheet on solving inequalities. You just had a bunch of fractions to begin with. You have to remember also that when you if I can find it, when you multiply, divide both sides of an inequality by a negative number, you have to reverse. So a bunch of little things you have to remember when solving inequalities. All right. Okay, so that is the end of this key.